Hi, we are from Group 3.
And our data is from
Johor, Sabah, and Sarawak.
And is from 2017 and 2022.
Hi everyone. Now we move on for the first part, which is introduction. In real life, cash crop plays a vital role in Malaysian economy, especially in supporting agriculture and trade. However, the level of production varies across different states and over time making it difficult to clearly identify patterns without proper statistical analysis. Therefore, this project focuses on a data set obtained from the Department of Statistics Malaysia, DOSM, where the selected indicator is cash crop production, and the comparison that we do is made between Sabah, Sarawak, and Johor over the period from 2019 to 2022. The aim of the study is to analyze and compare the distribution of cash crop production across these selected states using descriptive statistics. The guiding research question for this study is how does cash crop production is vary between Sabah, Sarawak, and Johor from 2019 to 2022, and what patterns can be identified from the data. So, to answer this question, we use SPSS to organize the data set into frequency tables to construct graphical representations such as histogram, OGIF, and frequency polygon. Oh, and don't forget to calculate the submarine statistic, which is including mean, variance, standard deviation, and quartiles to present data in a clear and meaningful way. I think that's all from me. So now we move on for the next part.
Our dataset is obtained from Department of Statistical Malaysia, which provides reliable and official statistical data. This dataset focuses on the cash crop planted area measured in hectares from three selected states in Malaysia, which are Johor, Sabah, and Sarawak. The data covers a period of 6 years from 2017 until 2022, allowing us to observe patterns over time. There are three main variables in this data set. The first is year, which represent the time period. The second is state, which is a categorical variable consisting of Johor, Sabah, and Sarawak. The third variable is the planted area in hectares, which is a numerical variable used for analysis. To organize the data, we group the values into class intervals for each state. From this, we constructed frequency tables, including frequency and cumulative frequency. We also calculated midpoints, upper bounds, and lower bounds, which are important for constructing graphs such as histograms, OGIFs, and frequency polygons. The purpose of this dataset is to compare the planted area of cash crops between the three states and to identify any differences or trends across the years. In conclusion, this analysis helps us understand how planted areas vary between Johor, Sabah, and Sarawak. From the result, we can see that there are noticeable differences between the states, which may be influenced by factors such as land availability, agricultural practices, and economic activities. Overall, the study shows that statistical tools such as frequency distributions and graphs are very useful in analyzing real-world data. Therefore, the objective of this study has been successfully achieved.
We have gathered data from these three states, which is Johor, Sabah, and Sarawak. We also created three histograms for these three states. On the horizontal vertical axis, we use class interval. On the vertical axis, we also use frequency. Okay, the next one is frequency polygon. For frequency polygon, we use midpoint and frequency, and we made into a frequency polygon for Sabah, Sarawak, and Johor. Okay, the next one is mean. The formula for mean is x equals ex divide n. For Johor, we use the data from above and we plus together and divide 6, and the final answer is this mean 3,374.57. For Sarawak and Sabah is also the same. Okay, the next one is standard deviation and squares. For Johor, the first column we use xi, and the second column xi minus x, and then the second column is xi minus x, the square, and for the last we use total e xi minus x square equals the total number. And for Sabah and Sarawak, we also do the same. Okay, the next one is variance. Johor, Sabah, and Sarawak. We use S2 equals the total number for the 434,000.80 divide 5 equals this number. For Sabah, we also do the same, and Sarawak we also do the same. Okay, the next one is standard deviation. So the Johor, we use square root, the square root 86,800.16, and then we get 294.62. And for Sabah and Sarawak, we also do the same. Okay, the next one is quartiles. For Johor, we use Q1 and median, which is Q2, equals the equation here, and then the final answer is 3,440.5. And for the Q3, we use 3,522.4. And for Sabah and Sarawak, we also do the same. Okay. The next one is interquartile range, stand for IQR. The formula for IQR is Q3 minus Q1. And for Johor, Sabah, and Sarawak is the same formula.
Now, let's move on to discussion and findings. In this section, we discuss the findings from our analysis of cash crop planted areas in Johor, Sabah, and Sarawak. Based on the results, Johor shows a stable and consistent pattern with most value ranging between 3,000 to 3,700 hectares. This indicates steady agricultural activity over the years. Sabah, on the other hand, records lower values, mostly between 1,200 to 2,000 hectares, suggesting a smaller scale of cash crop planting, although the trend remains consistent. In contrast, Sarawak shows the greatest variation. While most value fall within a normal range, there is one extremely high value which creates an outlier and increases the overall spread of the data. Overall, Johor has the most consistent pattern, Sabah has the lowest planted area, and Sarawak shows the highest variation. According to the Department of Statistics Malaysia, such differences may be influenced by factors such as land use, climate, and economic activity. Therefore, these findings supports our hypothesis. In conclusion, the analysis shows clear differences in cash crop planted areas between Johor, Sabah, and Sarawak. Johor demonstrates the most stable and consistent pattern. Sabah records the lowest planted area, while Sarawak shows the greatest variation due to an extreme value. Overall, these findings highlight the importance of using statistical analysis to better understand real-world agricultural patterns.